Hello, and thank you for joining Getting Started with Identity on AWS. I'm Mark Shalkevich, Senior Identity Go-to-Market Specialist with Amazon Web Services. This presentation will focus on an introduction to identity in AWS. We'll review the mental model of AWS identity, that is, how we in AWS think about identity. AWS identity in terms of identity, access, and resource management, which I'll also refer to as the pillars. Access into AWS, that is, into the AWS cloud, and AWS accounts, so we get a refresher on that. We'll also discuss multi-account governance, and we'll talk about some tools and some additional services. In terms of identity, the mental model used by AWS is fairly simple. Who can access what? Looking at this model of who can access what in terms of identity, access, and resource management, the who consists of name, credentials, and metadata. The can access is about the policies and compliance, and the what is about isolation, grouping, tagging, and sharing. Of course, governance is considered across all three. For example, governance could determine if someone can connect an external IDP as the identity source, or have some level of guardrails around how resource sharing works, or perhaps to gather and present information on who can access what. And the mental model of who can access what aligns to the identity, access, and resource management pillars. The who in our mental model from an AWS identity management perspective has two types of identity services, workforce and consumer. Workforce identity includes several AWS identity services. First, AWS Identity and Access Management, and many refer to this as IAM. Then we have AWS Directory Service, which itself has several services under its naming, including AWS Directory Service for Microsoft Active Directory, and you use this if you need an actual Microsoft Active Directory in the AWS cloud that supports Active Directory-aware workloads, or AWS applications and services such as Amazon Workspaces and Amazon QuickSight, or if you need LDAP support for Linux applications. Also under the Directory Services umbrella is AD Connector, and you use this if you need to allow your on-premises users to log into AWS applications and services with their Active Directory credentials. And of course, AWS SSO, which we'll discuss in further detail in a few minutes. For consumer identity, we have Amazon Cognito, which is used for high-scale SaaS applications when a scalable directory is needed to manage and authenticate subscribers that works with social media identities. This presentation predominantly focuses on workforce identity. I've talked about the AWS services for who, which is the identity management pillar. Now let's cover the can access, or the access management pillar. AWS does this through policies. A policy is an object in AWS that, when associated with identity or resources, defines their permissions. AWS evaluates these policies when a principal uses an entity, that is, a user or a role, to make a request. Permissions in the policies determine whether the request is allowed or denied. Actions or resources that are not explicitly allowed are denied by default. And most policies are stored in AWS as JSON documents. AWS has different types of policies. Here we're just highlighting two IAM policies, identity and resource-based policies. The identity-based policies, they focus on the user. In other words, they can be attached to a user, a group, or a role to grant them permission. The policy specifies what that identity, that is that user, can do to the resources. For example, a policy can be created to allow the identity to start an EC2 instance, but not stop it. Resource-based policies are policies that are attached to a resource and focus on which principal can perform action on the resource to which the policy is attached. Most common use of a resource-based policy is for an S3 bucket. For example, a resource-based policy can allow user 1 and user 2 to perform all actions on the S3 bucket, while other users are not allowed to access the bucket at all. Both identity and resource-based policies that you see here are permissions policies, and they're evaluated together. For requests to which only permission policies apply, AWS first checks all policies for a deny. If it exists, then the request is denied. Then AWS checks for each allow. If at least one of these policy statements allow the action in the request is allowed. It doesn't matter whether the allow is in the identity or the resource-based policy. Of course, there are several other policy types. For example, service control policies, or SCPs, that are a type of policy that offer central control over the maximum available permissions for all accounts in something we'll discuss in a few minutes, your AWS organization. Said another way, SCPs define the guardrail permissions, also known as preventative guardrails, to AWS accounts. They ensure that your accounts maintain compliance because they disallow actions that lead to policy violations. And another example are session policies, which are permissions that are passed using the AWS CLI, command line interface, or AWS APIs to assume a role by a federated user. Now, let's move to the what. In the who can access what model, or the pillar we call resource management. Managing identities is just part of the equation. There's also a need to manage resources such as files, EC2 instances, satellites, etc., etc., etc. We need to manage resources at cloud scale for hundreds of AWS accounts, thousands of Amazon EC2 instances, billions of Amazon S3 objects, trillions of Amazon DynamoDB items, and some customers have as many as thousands of workloads. The challenge here is the ever-growing number of resources. So your complexity may not be as high, but the point is that scale is going up and to the right. This means that we need to have a more scalable way of managing resources that isn't always at the individual resource level. So managing resources at scale can be broken down into 3 steps. Find my stuff, which is to find all the resources that belong to Project Blue. Organize my stuff, group all of the resources that belong to Project Blue together, and manage my stuff. Allow only Project Blue developers to access the resources that are in Project Blue. This is known as tag policies, which can be attached to principals such as users or roles and to AWS resources. If the tag on the principal matches the tag on the resource, access is allowed. In this example, only the user with the tag blue can access the resources tagged with blue. And AWS Resource Group's tag editor can be used to add tags to or edit tags of multiple resources at one time. And with all that, the 3 pillars of identity, access, and resource management, or the mental model that we use for identity of who can access what, when we pull all this together, it provides for fine-grained access control capabilities. We can control access based on specific services, actions, resources, and conditions. So for example, you can use an Amazon EC2 instance that you can launch only in a particular subnet, only in an approved region, or cost center. Well, now that we've completed talking about how we view the identity mental model of who can access what, and the related 3 pillars of identity, access, and resource management, through how they provide for fine-grained access controls, let's shift a little bit and talk about how to access AWS. The guidance is to start with AWS SSO, which you see presented with the icon in the lower left corner. AWS SSO is a cloud-based identity service that is essentially used for entry into AWS. It provides central control for your workforce's identities to all the AWS accounts you've granted them access to, as well as to the AWS enterprise applications such as Amazon SageMaker or AWS IoT, Sitewise, or to hundreds of SAML-based SaaS applications such as Jira, Slack, and ServiceNow. AWS SSO is tightly integrated with AWS organizations to help you manage access and user permissions across all your accounts. For clarity, to use AWS SSO, AWS organizations is required with all features set to enabled. We'll discuss AWS organizations in a moment. To access AWS, you can use AWS SSO's built-in native directory as your primary identity store, or quickly connect to and automatically sync with another workforce identity system such as Okta, Azure AD, or other third-party identity providers, as well as AWS-managed Microsoft Active Directory. You can protect AWS resources with consistent roles, security policies, and strong user authentication mechanisms with multi-factor authentication as well. In short, what this gives you is one access control model, and you choose your identity source. And using AWS SSO is as easy as 1, 2, 3, 4, 5. Choose an identity source, you define your role-oriented permission sets, and then you assign groups and users to those permission sets in your selected accounts. For application access, which is the 4 and 5, you connect cloud apps with SAML, and then you assign groups and users to the apps. Here we show that AWS SSO can connect to an external IDP such as Okta or Azure AD with normal SAML 2.0. As well, synchronization can be achieved by using the System for Cross-Domain Identity Management, or typically referred to as SCIM. Of course, SCIM is optional, but it's highly recommended, and as noted in the slide, ensure to synchronize email attributes. So we've covered the AWS Identity Mental Model, then AWS services to implement that model, and the suggested way to enter AWS. Let's keep that in mind as we now discuss an AWS account. This is to ensure an understanding of AWS accounts, what they are, and suggestions for how to use them. One of the ways in which customers can have both the speed and security is by utilizing accounts. Customers sign up for AWS by creating an account, which is the management or payer account. Then they start building resources and deploying services within the account as they build their environment. Accounts are essentially resource containers that assist users in managing AWS resources, explicit security boundaries. They are containers for cost tracking and billing, and they are a mechanism to enforce limits and thresholds such as service quotas or API thresholds. And as needs and demands grow, environments scale by adding new accounts. This is a best practice, so I'd like to discuss this just a little bit more. Scaling through account creation, that is using a multi-account model, is a best practice because it provides many benefits for our customers. It enables rapid innovation across distributed teams and individuals. It's similar to how customers can spin up EC2 instances in minutes. You can create and provision new accounts in AWS resources for your teams in minutes. You can deploy or adjust accounts to meet new business processes, such as when you need to define a set of workloads based on operational, regulatory, and budgetary requirements. Billing is incurred at the account level, so activity and costs can be identified with each account. And new accounts reduce the blast radius via isolation. For example, a potential issue in one account is contained within that account, and it cannot impact other accounts. In addition, accounts are natural resource boundaries, where access to one account does not cross over into other accounts without first allowing permissions. It's worth noting that not all of our customers start with a single account. Some may migrate to AWS and set up multiple accounts to get started, and they can achieve the same benefits that we're describing here. And of course, with the use of accounts, we need to discuss how to manage them at scale. So let's talk about AWS organizations. AWS Organizations is a service that provides you with the tools to centrally manage and govern your cloud environment. You can quickly scale your environment by creating accounts and allocating resources. You can customize your environment in multiple ways by applying governance policies. You can secure and audit your environment, and you can manage costs and identify cost-saving measures. There is no cost to enabling AWS Organizations, so I highly encourage you to implement it and use it. AWS Organizations is a powerful tool because it allows you to manage your cloud environment while utilizing multiple accounts. This diagram represents a fully functional organization. The organization outlined in red consists of a single management account and multiple member accounts grouped into organizational units. Organizational units, or OUs, shown here in the blue squares, allow you to group accounts by function or by purpose. You can use OUs to develop custom environments for your users or teams by applying various policies at the OU level. In this diagram, you can see we have separate OUs for infrastructure, security, Sandbox, and a few others. There are also nested OUs in security, infrastructure, and workloads, which allow you to separate your production accounts from your development accounts. Now, this is a best practice as it allows you to ensure certain safeguards are in place to prevent unexpected issues with your production environment. Member accounts in your organization are noted with triangles at the bottom of that left side screen. This is just a high-level view to show the power of centrally managing multiple accounts across an organization. It gives your teams the space and permissions to manage their respective areas in your cloud environment while ensuring you take advantage of scaling and the security benefits of multiple accounts. So let's ensure that we understand AWS Organization's benefits before moving on. It provides native capabilities along with providing features for a number of AWS services to operate across accounts. There are four main categories of features that AWS Organizations unlocks for customers: centrally provisioning accounts and resources, sharing resources and controlling access to accounts, regions, and services, securing and auditing your environment for compliance, and optimizing costs and identifying cost-saving measures. There are a lot of customizations available for an organization, so we want to go through 5 quick actions that any new or existing org can take when getting started. Once you create your organization, we recommend that you create your account structure, specifically your security OU and accounts. You can then enable security services across the organization, such as threat detection with GuardDuty, privacy controls with Macie, or configuration rules with AWS Config. You can activate the service at the organization level, then delegate them to the security account that you created, which allows your security team to manage these services across the organization. The next step that most customers take is to deploy important resources, such as read-only roles for your security team in all the accounts using AWS StackSets. And StackSets is integrated with AWS Organizations and can automatically roll out these required resources to newly created accounts. After that, customers tend to set overall policy for tags, backups, and access, which are the SCPs or service control policies that we just recently discussed. Now that we have some governance rules in place, AWS is a logical next step to start granting access to different user populations, followed closely with AWS Resource Access Manager to share commonly used resources. AWS Organizations gives you those native tools to build your environment, but if you'd like to jumpstart your AWS environment using a simple UI and built-in best practices, I'd like to introduce you to and discuss AWS Control Tower. Control Tower is built on top of organizations, and it assists customers to achieve a secure multi-account environment known as a landing zone. It uses a combination of automated features from organizations, AWS Config, and other services to assist in maintaining guardrails, which are the SCPs we talked about, or configuration rules, blueprints, which are the OUs and organization structure that we showed, and account vending, which provision new accounts and services. Control Tower provides an easy interface to build the multi-account landing zone with a predefined OU structure and default policies, which are those guardrails that we discussed. It abstracts these services to automatically include the best practices we recommend for customers to manage their environment. We recommend Control Tower for newer customers who want a simple solution for building out their environment, and they can still use the underlying AWS services if you'd like to customize or build your environment outside of Control Tower. And with that, we've covered the identity mental model, AWS Workforce Services supporting that model. We discussed how to access AWS, what an account is, how to manage and govern a multi-account model with AWS Organizations, and how to quickly build out that model with Control Tower. So let's talk about afterwards, when you're up and running. Customers tell us that they desire to grant their employees least privilege, which is the right access to the right things at the right time to do their job, but nothing more. But how do you know you're achieving least privilege over time? Typically, you have to widen permissions during dev, but how do you know you can safely shrink permissions as you move to production? For this, we provide last accessed information, such as last accessed and role last used timestamps to refine your policies and allow access to only the services and actions that your entities use. You can easily remove unused permissions with confidence. And for unintended access, Access Analyzer, a feature of IAM that continuously monitors and analyzes access control policies to help teams centrally identify resources accessible from outside an account. It's fast, so it quickly analyzes thousands of policies in just a few seconds. It analyzes policies from S3 buckets, KMS keys, SQS queues, IAM roles, Lambda functions. It's the first service powered by automatic reasoning. It is comprehensive. It uses mathematics to comprehensively assess all access paths, not predictions based on historical access patterns. All possible paths are verified by mathematical proofs done by a type of cognitive science called automatic reasoning. And it is available to you for free. And you can use Access Analyzer to centrally analyze access across your entire AWS organization. So let's summarize what we discussed. The AWS mental model of identity is who can access what, which is reflected in the pillars of identity management, so you use AWS SSO to manage users centrally. Access management, which are policies to define permissions. Resource management, which use tag policies, and they're just not for billing anymore. We discussed how to scale to use multiple accounts, and we have AWS organizations to centrally control access, manage billing, and share resources across your AWS accounts. We have AWS Control Tower to set up and govern a secure multi-account environment. And we discussed least privilege. IAM Access Analyzer and role last used. This reduces unnecessary permissions, and you can use IAM Access Analyzer to identify unintended access. And lastly, support building out your own community of identity professionals. To learn more, I provided some references on the information that we discussed on identity, IAM, single sign-on, directory services, organizations, Control Tower, as well as some consumer identities on aws.amazon.com. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS Training and Certification for Security. According to Global Knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent, so training's never been more important. We offer more than 25 digital and classroom courses for you and your teams around security, identity, and compliance. And you can also showcase your expertise by pursuing the AWS Certified Security Specialty Certification. I'd like to thank you very much, and please remember to complete your session survey.